This demonstration streamlines the chi-square test on TI-8384 calculators. I was informed through an email that there is a better way to conduct a chi-square test on these calculators. And this video is to demonstrate how this is done. We'll take the following example to demonstrate this. Suppose we flip a coin and obtain 2,048 heads and 1,992 tails. Then we spin the same coin and obtain 953 heads and 1,047 tails. We're going to run a chi-square test of homogeneity for this example. And homogeneity tests are used to see if proportions of two methods are statistically equal. So to conduct a chi-square test on the calculator, we may proceed by entering the observed data into a matrix. So we'll go ahead and go under Matrix. We'll select Matrix A, and we will type in the dimensions. This one's 2 by 2, and then we'll begin entering in the observed data. We enter in the first row as the numbers we obtained when we flipped the coin. The second row will be the numbers we obtained when we spun the coin. The first column are the heads, the second column are the tails. Now that we have our observed values entered into Matrix A, we may conduct the test, and here's how. We go back to the home screen, and we select Stat, and we go over to Tests, and then we scroll until we get to chi-square test, this first one here. Right, now the observed is where we typed in our observed data. That's in Matrix A right here. Now the expected will be stored in Matrix B. In my previous video I mentioned that you would have to compute the expected counts and store them in this matrix before running this test. This is in fact not true. The calculator will compute the expected counts and store them in Matrix B. And that was what the email informed me of, so I thank the people who emailed me to make this correction. Then we may choose Calculate, and it will go through and perform the calculations. So we'll go ahead and scroll down to Calculate. And here are the results. Chi-square, that is the test statistic, the computation from running the sum of the squares of the differences between the observed and the expected counts, that square divided by the expected counts and then summed up. The p-value is the chance of seeing such a result or something more extreme. In this case it's about 0.026 or about 2.6%. And the degrees of freedom are 1, and this helps us get an idea about what the shape of the distribution is when we take our measurements. Now let's examine these expected counts. According to our test, we stored the results in Matrix B, so we'll go ahead and display this matrix to the home screen, just to make sure that it computed them, or if you just want to see what these expected counts are. So we'll go ahead and do that. We'll go under Matrix, which is the second and the reciprocal key on the 84. We'll select Matrix B, and we'll simply display it to the screen by hitting Enter. So here we can see the expected counts for this particular test. This first entry, 2007.29, this is what we would expect to see if we conducted this experiment. And we can see that there's some ellipsis here, so we can go ahead and scroll to see the rest of the numbers. So each entry in this matrix represents the expected count for the number of heads and number of tails as compared with whether we flipped the coin or spun the coin. And here we can scroll through until we see all the digits. And this is how you can conduct a chi-square test without having to compute the actual expected counts. The calculator will do it for you. And again, I thank the people who informed me of this.